Hi friends, welcome to GMT tutorials. Now we are going to discussing about the multiplexer concept, that is nothing but 4 by 1 marks. In the previous classes we discussed regarding the introduction part as well as 2 by 1 marks operation. Now we are going to focusing on 4 by 1 marks. So please subscribe my channel if you are not subscribed to my channel up to now. Okay, it helps a lot for me. Thank you for your support. So let us see the 4 by 1 multiplexer. Okay, so let us see the block diagram or a graphical representation for 4 by 1 marks. This is a graphical representation for 4 by 1 marks. So in case of the 4 by 1 marks, total number of inputs we have 4 inputs is there, that is nothing but I naught, selection line I2, I2, I3. So it is a 4 by 1 marks. So total number of selection lines we have to, if you want to select the total number of inputs, obviously we need a total number of selection lines, yes, not yes one. Okay, so this is a graphical, this figure shows the graphical representation, graphical representation. So basic criteria we know that generally where m is equal to selection lines, I will take m is a selection, two selection lines is there, total number of n is the input lines, so we have a 4 input lines is there. So basic criteria 2 power m is equal to total number of input lines formula. So 2 power 2, that is equal to 4 inputs is there, 4 input lines is there. If you want to know the m value, log n base 2, so log of n value 4, so log of 2 square, so this value is equal to 2 log 2 base 2, so this value is equal to, so total number of selection lines in case of the 4 by 1 mux is equal to 2. So this is also, if you know the total number of selection lines, you can directly decide the total number of input lines also, right? So now see the truth table for this 4 by 1 mux. The truth table for 4 by 1 mux is equal to, okay, I will select truth table for selection lines and function values, right? So S0 is a selection line and one more selection line is S1, S1, the output function F. Suppose if you are selecting 0 0, it selects only I0 value. In case 0 1, it selects the I1 value. If you are selecting, if you are giving the selection inputs as 1 0, it selects the I2 value. 1 1 consideration, it selects the I3. So this is a truth table for 4 by 1 marks. Okay, 4 by 1 marks ki manukuన్న possible truth table. Okay, so this is a truth table for 4 by 1 marks. Okay, okay, this is the select truth table. Now we have to design the logic diagram for this one. Okay, logic diagram. So if you want to draw the logic diagram, first of all, what are the possible input combinations? That is nothing but I will draw S1 is not. Okay, complement of that one can be treated as not gate. Is the S value. Okay, as well as, so if you know this one, we can draw the. Okay, so first of all, when S is equal, S naught is equal to 0 and S1 is equal to 0, both 0 0 consideration, it selects the I naught value, right? So I will take S naught bar and the S1 bar. At the time it selects the I1 value. Okay, this is the given to AND gate. Okay, next, for another possible, so this is nothing but I will treat I naught. Okay, next I1 is selected 0 1 when this is equal to S1 is equal to 0. Okay, this is nothing but S1 is equal to S naught is equal to 1 consideration, right? So this is over, right? These two cases is over. Next, S naught is equal to 1. S naught is equal to 1 means this line. Next, S1 is equal to 0 line, right? So S1 is 0 and it selects the I naught. I naught is the input. Okay. Next, another possibilities is there. I2 combination, it selects the I2 value. When I2 is equal to 1, S1 is equal to 1 and S0 value is 0. This is for I2. The last combination is nothing but I3. It selects the I3 value when both are 1 1 consideration. If you are extending this line, okay. Just I will draw this one first. It is easy for you. But I can, okay. Now I will extend this line. For I3, how we are going to select? I3 is this line, okay. When I3, if you want to select I3, what are the possible combination? Both S0 and S1 values are must be 1. Then only it selects the corresponding values. See here. What is the S1 line here? This is a S1 line. This is nothing but S0 line. Okay. This is for I3. Okay. So if you want to realize this, all these are connected to the one OR gate. Okay, 4 input OR gate. Just I will treat this function as here. So this is a logic diagram for 4 by 1 multiplexer. Okay, this is a logic diagram for 4 by multiplexer. Okay, see the possible combinations for like if you want to select f is equal to, so f is equal to, see here the next diagram 4 by 1 max, where f is equal to here. First, if you want to select the I0 value, what is the possible combination? F is equal to I0 at that time S1 bar S0 bar. At the same time, f is equal to I1 consideration S1 bar and S0. For f is equal to I2 case 10 S0 bar. At the same time, f is equal to I3 S. So this is a scenario for possible combinations if you want to select the corresponding 4 by 1 marks. So let us see the possibilities for first consideration. When s is equal to 0, that means S0 0, S1 0 case, what happens? F is equal to I0, S1 bar means at 1, S1 bar is also, therefore it selects only I0 value. So in the remaining all cases, so see the possibilities for second consideration here also. So I1, S1 is equal to 0, actually S1 bar means that, wait a minute, just I can represent S1, it is this S1. Okay. So S1 bar means that it is the 1 value. S0 is equal to 0. Therefore, 1 into 0. This complete term is equal to 0. For this case also, I2 into S1 is equal to 0, 1. So this is also equal to 0. So for this case also, I3, both are 0, 0. So for S is equal to 0, S0 is equal to 0 and S1 is equal to 0 cases, only it selects the I0 value. In all the remaining values are going to be 0. Okay, this is a way you have to how the multiplexer 4 by 1 multiplexer is going to be work for the corresponding circuit diagrams. Okay, this is a truth table and a logic diagram for this one. If you know this, we can write the theory point of views. Okay, let us see in our mother terminology also. So 4x1 multiplexer అంటే ఏం లేదు ఇక్కడ. ఫోర్ ఇన్పుట్స్ ఉంటాయి, మనం ఒక అవుట్పుట్ మాత్రమే సెలెక్ట్ చేసుకోవాలి. ఆ ఒక్క అవుట్పుట్ దేని బేస్ చేసుకొని సెలెక్ట్ చేసుకుంటా అంటే బేస్డ్ ఆన్ ది సెలెక్షన్ లైన్స్. The total number of selection lines in case of the 4x1 multiplexer is 2 only. Okay, if S0 and S1 are the two input selection lines, both are 0 0, at that time it selects only I1 value. Okay, this is the truth table. Both are 0 0 consideration, it selects only I1 value. When 0 1 consideration, that means S1 0 and S0 1 value and 1 then it selects the I1 value. Okay, at the same time in the third consideration, so third consideration, when S1 is equal to 1 IE, S0 is equal to 0 it selects the I2 value. That this is a possible consideration. Okay, so based on this process it selects the corresponding value. So this is a logic diagram. This S0 is a selection lines, these two are selection lines, these are the input lines. Okay, so this is a output function. F is a output function. Okay, so this is a operation of 4x1 multiplexer. I hope this video is very helpful for you. Okay, if you want to designing the 4x1 mux, we can, with the help of a 2x1 mux is also we can designing this. Okay, so let us see just a brief way how this we are going to design. If you want to designing a 4x1 mux, it can be designed by using two 2x1 multiplexers. So in case of the 4x1 mux, total number of inputs is equal to I0, I1, 4 inputs are there, therefore I will select I2 and I3. Obviously we need one selection line, so for this one these two muxes are connected to only one selection line. Okay, I will call S0. Okay, again this is a 2x1 mux, one input one output is there, these two are connected to one more 2x1 mux, therefore 2x1 it is also a 2x1 mux, it is also a 2x1 mux. So this is nothing but a output. So this is, I will rate this a S1. This is called as a. So based on this 4x1 mux can be represented, 4x1 mux can be designed with the help of a 2x1 multiplexers also. Okay, so this is a way you have to select the. So these are the possible consideration. So let us see in the first case, when selection line S0 is equal to 0, what are the possibilities? So S0 is equal to 0 means that here the consideration, right? So this is a consideration 0 case. In this first multiplexer it selects the I0 value, right? So in this consideration it selects the I2 value. So let us see S1 is equal to 0 for first case. Okay, it selects I0 comma I2. So here S0 is equal to 0, S1 is equal to 0, therefore it selects the first value, therefore I0 is selected. At the same time, when S0 is equal to 1, what is the consideration? It selects the I1 here, it selects the I3 here. If you are selecting S1 is equal to again 0 consideration, that means you have to see the possibilities first. So S1 is equal to 0, it selects the I1 value. So here possible inputs is for last multiplexer is equal to I1 comma I2. It selects only first one for I1. Okay, in the remaining cases when S1 is equal to 1 possibility. So let us see the possibilities for S1 is equal to 1 consideration. When S1 is equal to 1, which selects the. Okay, so this is a case for S1 is equal to 0. When S1 is equal to 1 consideration, it selects the I2 and it selects the I3. Okay, this is the I3 action. So based on this, you can select the particular multiplexer. This is the scenario. Okay, if you want to designing the 8 by 1 mux also, we can same process we have to follow this one. So this is a multiplexer concept in case of the 4 by 1 mux. Okay, thank you for watching GMK tutorials. Thank you for your support.